So anyways, my talk is contextually about Docker, but it really can apply to sort of any sort of deployment mechanism that you're looking to implement or refine. Docker's kind of easy to talk about because everyone's kind of excited about it. It's very much a big deal right now. But also it's sort of artifact driven, which is a great way to run a pipeline. When you have something that doesn't have to change from development to production, it makes things very consistent, removes variables, and so it's kind of nice to look at a deployment pipeline or continuous integration using Docker because it kind of follows a lot of nice patterns. So a little bit about me. I've been in IT for about 18 years now. I started fixing computers way back in the day, probably like many of you. I've worked in big businesses and small businesses. Right now, I work for a company called StatFlow that does wireless carrier analytics and CRM and sort of tries to fix customer service in the wireless world. But I'm not going to talk about that. I also throw frisbees all the time, so that's my fun fact. So what's really the context and the value of this this talk? If you can't see from that, this is a guy mopping a driveway in the rain, which I like. This is what happens when you join the military. But what I want to do is sort of put this in a frame of reference that makes sense to people, so that you can sort of apply it, even if you're not using Docker, or if you've got some sort of a deployment pipeline right now and you want to refine it. Docker's a really big thing right now. It's not that it's a big deal, but it's very large and nebulous, right? It's constantly changing, and it's really complicated once you get into the weeds and start looking at the details. There's a lot of misconceptions and misunderstandings around what it takes to run properly, how you can get started, and how to live with it on a daily basis. So hopefully I can sort of frame some things that will remove some mystery or simplify things a little bit, give you some paradigms that you could take back and make you a little bit more productive, or make it less scary, or maybe more scary, depending on what you've heard and what your assumptions are about it. Because it's not really that apparent inside of the whole Docker reality distortion field. Like, they've got their own sort of Apple thing going where it's like, when they talk about it, everything is perfect and it's the magical sprinkles for every problem inside of a startup or an enterprise, right? But that's really not the case. It takes a lot of attention to think about how you should apply it and how it could be valuable to you, because it's different for everybody. It's like any sort of advanced technology. You really have to look at it in your own context and have it make sense to your organization. So why do we need a pipeline in the first place? And why do we talk about pipelines and things like continuous integration and continuous delivery? What we really want to do inside of an organization is ship often and ship very easily, so that we can do it 100 times a day if we wanted to, right? Nobody would want to do that manually, but we want to be able to do this for many reasons. So why would we want to do something like shipping code 100 times a day? It's not so much that you're hitting some kind of a magical number with that. It could be 10 times a day. It could be 1 time a month. But really what you want to do when you're focusing on shipping rapidly is focusing on the fact that you've probably worked out the kinks, right? You've probably worked out all the wrinkles in your process if you can do it 100 times a day. And that's what you want to be aiming for, is something that's repeatable, something that's consistent, something that you can apply over and over again and not have to worry about it changing every single time and affecting your workflow or the outcome, right? Consistency is going to remove those variables that allows you to really improve the process and get better at it, right? So aiming for shipping 100 times a day, you're going to fall short on the road. But if you keep that as a target, then you're going to think of, okay, if I'm doing this manually right now, what's what does it look like in 6 months when I'm still doing it manually, right? Should I look at ways of automating things or making things more consistent so that we can continually optimize our processes? And so if you can do it 100 times a day, chances are it's fully automated, right? Chances are there's no human intervention. Nobody has to sort of press a button or get in the way of the process. And that makes it safer and more consistent. And you're going to have a lot less variable the less you involve humans in the process. And when we think about sort of a pipeline and shepherding things from development into production, there's a lot of parallels to manufacturing. So you'll hear people talk a lot about manufacturing theory and iterative processes and repeatable processes and waste and all of those things. And they're all very appropriate. So once you get into this quite a bit, you might look at things like value stream mapping or classical manufacturing theory, because they've all dealt with this before. Like, manufacturing has had pipeline problems for 100 years. So it's kind of interesting to look at things in terms of the historical context as well. So we start off where everything is really crappy and broken, and that's fine, right? Your pipeline could be that you have someone on your team go onto a server and check out code, or even just FTP it to a server, right? And then maybe they change a symlink, and that's it. That's all you've got. You have no testing, you have nothing. But you're starting from something, right? And the point is to iterate on whatever you have and just gradually improve. You don't want to aim for the stars from the beginning. So that would be something that I want to have you sort of keep in mind as we go through this. Don't worry if it all gets really complicated. I want to talk about sort of the beginning and then the end state and a fully mature state so that we can sort of establish context, but don't worry about doing everything at once or managing all of the complexity of a fully mature system. So back to the pipeline. I want to sort of define some general terms about a pipeline just so that we can set up the talk a little bit better and make sure that everyone's on the same page. So pieces of a pipeline really consist of a natural start and end state, right? A start and a beginning, obviously. It commonly starts with source control, so you'll have something like Git or SVN, some kind of a commit of code, right? A unit of change, because change is really the trigger for the entire process to begin. You're not going to be running a pipeline for no reason if you can avoid it, because it does take time. And regardless of how automated it is, you want to make sure that you only run it when you have to run it, because there's overhead involved in that. And you don't want to generate a lot of noise as well. So you tend to kick it off when someone pushes code from a development machine to a centralized location, be that version control or let's say S3 if you're shipping an artifact directly from a developer laptop. You can run them parallel or sequentially. So a lot of times people will run into problems where they start slowing down when they get increasingly complex, and you can run steps in parallel because they don't really depend on one starting after the other finishes. But that's kind of an advanced pattern that you'll get to. And the successful measurement of a pipeline deployment is code in production, right? You can go a little bit shy of that if you're looking for just continuous delivery and have your code ready to deploy to production, and that's fine. That's fine. But if you want to fully automate the start to finish, it means that your code is in production once you're done one iteration of your pipeline. So I want to start talking with continuous delivery because that's sort of the main pattern that everyone is sort of striving for. Continuous deployment really varies whether or not you're in an organization that will support that, but continuous delivery sort of applies to everybody. The definition around continuous delivery is you are able to deploy to production. You don't automatically do it. Continuous deployment is your automatic deployment to production. But continuous delivery means that you're able to if you want. And you sort of end your pipeline with a release, which means that you can ship to production if you wanted to. And the steps there are change, validate. This is a general term for sort of testing and making sure that your change is actually worth deploying or is of high quality. Stabilize would be your sort of artifact step where you're assembling all the components, getting it all ready to go to production. And then you deploy however you want. So in terms of actual applicable terms, you'll see like a code change, then running tests, then running some kind of a build or compile step, and then you deploy to production. And code sort of flows upstream to downstream. Upstream being the left side, downstream being the right. So there's sort of stages of maturity involved as well. So you can deploy directly, as I was saying. You can sort of take your code and just FTP it to a server, and that's okay. If you're just starting out, that's usually how you do things. Don't try to overcomplicate it. But very soon you're going to start to want to validate, especially when you're working in teams. You want to make sure that your changes are of high quality because you don't want to be screwing over somebody else who's relying on that change. You want to have a little bit more confidence and safety in the fact that you're deploying, because you're probably changing a running system and you want to make sure that it's safe. So you want to increase your confidence by doing something like continuous integration, which means that you're testing code that is a delta or a change from your current state, and you want to make sure that when you merge your future state into your current state, there's no issues. So that's commonly what happens when you have like a git merge to master. You'll see a lot of patterns where people are deploying from a develop branch to a CI environment, and then they'll merge it down to master, and master means that it's ready to go to production. That's a common convention. So continuous delivery, again, is just ensuring that it's of high quality and ready to deliver, and it's basically in a position where you can push a button and have it deployed. Continuous deployment, as we already covered, just ships the whole thing right through. And you can get there when you have a really high level of confidence and a really high level of automation. So once you're really confident with your test coverage, you've got 85% test coverage, and you know that your critical path is pretty much automatically tested, you can go ahead and say, ship to production, and I'm going to run a bunch of validation steps automatically, and that's going to tell me whether or not it's a good idea to deploy or not. So you'll see this in organizations like Netflix and Etsy. They will automatically deploy certain areas of their apps. I don't think they fully automate everything, but at a certain point, you gain a level of confidence where you're like, all my automated testing is more sophisticated and more attentive than a human could ever be, so we might as well just ship it directly. So the reason why a pipeline is so useful and such a sort of desired component of software development is because sort of the alternative is you cranking out a bunch of code and then throwing it over to like an operations team and saying, you guys go deal with this, right? If you've got a pipeline in place, I actually can't stop this from happening. So I'm gonna be here for a while too, but no. What would happen commonly, it's so distracting. I'm sorry. You can just loop the video like afterwards if you really like it. I'll post the link. That always gets too many laughs for its own good. So what happened, in the past, and a lot of people still deal with this, is that they have code that is crafted in development, and then it gets thrown to operations, and operations has to deal with it, often with very little context, right? Doesn't come with like a huge sophisticated README or some kind of scripted automation. And that became a problem, and that's sort of where DevOps came from, is the industry got to a point where we could deploy software, we could build software really, really fast, and then it would always crash into ops and be this giant problem that they had to deal with because we started moving so quickly on the dev side. And so we want a pipeline as an ideal state because what happens is it sort of smooths that transition, right, and automates all the way through. So it sort of represents the unification of those two words, dev and ops, by bringing the two into the same process, right? A very cohesive start to finish that involves both departments, and ideally a lot of components that are critical to both sides feeling confident in the change. So why is Docker valuable here? Docker is more than just, I can spin up a Hadoop cluster or Elasticsearch or some kind of Redis really easily, right? Because someone else has already built it and I can just say Docker run. What's really, really valuable is that you get a high degree of sort of portability with Docker. You can componentize things very easily. And you get this degree of sort of reusable infrastructure that scales very, very well, right? It will run in many more places than typical packages and configurations. And you can do really nice things like have services auto-configure and stuff. And I'll get into more detail about some advantages. But there's also a lot of costs. So just a quick note about sort of caveats. Before we all fall in love with Docker, it's changing a lot, right? There's been a lot of evolution over the past 12 months, past 2 years. And, there are breaking changes. There's things like I believe today they announced that 1.5, like anything built in 1.5 is now no longer valid on the Docker Hub, and they're going to be like kicking it off. So you have to sort of be comfortable with a very high change, high turnover, highly agile environment that you're going to have to sort of ride the wave as it goes because it's going to move quickly for a while. And there are lots of moving parts outside of just Docker itself. There's also other options in the ecosystem, right? There's Rocket is another container format, Docker being just a container format that does a lot of things that other things can do. So there will be competition to Docker. There already is to a certain degree, and that's not going to stop anytime soon. So there will be alternatives. There's going to be people doing things in different ways, and that's fine. That's healthy. Just recently they launched the Open Container Initiative, so trying to sort of agnosticize things away from Docker being a company that owns all of this to something a little bit more flexible for multiple participants to collaborate on and something more open source oriented. So you'll see a lot of changes there, but as Docker is right now, there's a lot you can do with it, and it's pretty great for certain use cases. So it's sort of complicated right now. This is actually a really old slide. I just didn't want to make my own, so I stole it. But basically, you've got like all kinds of players in the game, all kinds of supported platforms. You can still use all your sort of traditional configuration management techniques and tools if you wanted to. You can bolt all kinds of stuff onto Docker. There's a lot of great use cases for big data, if anyone's dealing with that, probably outside the scope of this conference. But there's a lot going on here. There's a lot of moving pieces. There's more people joining all the time. If I had to speculate, I'd say this slide is probably twice or three times the size right now. I think this is late 2014. But now we can get on to advantages, right? Because you're fully disillusioned with the idea of like using Docker at all by now. So let's pick that up and say that essentially I would say the main advantages of Docker are that it makes tooling consistent. So you can now sort of run any sort of one-time application or any kind of tool. Let's say you use S3 command, right, to ship things to S3, right? And you don't want to actually install that on your developer laptop or move it from place to place. Let's say you have something that you run for a specific purpose, but it comes with a lot of dependencies. There's a virtual environment, right, if you're in the Python world, or you've got gems and you're in the Ruby world. Having to install that on your local machine and have it not stomp on everything is a super pain, right? Like nobody runs Nobody can run the same version of Ruby for everything that they want to. Is just not realistic. And the same happens with Python, right? And so what we've traditionally done in the past is have virtual machines, right? So you'll start up a virtual machine in VirtualBox or in VMware, put all your crap in there, and then you've got this huge, like 2 gig drain on your laptop all the time, right? And it gets out of date. It's got to be configured with some kind of configuration management or manually, and that's kind of a pain, right? But Docker, you can sort of install all those tools as individual containers and then call them to run the tool. And I'm not going to get into the specifics of that because it's a little bit outside of scope, but I'm happy to talk to anyone about how I do things there afterwards. It also makes environments consistent, right? So from one server to another, you can have a high degree of confidence that you know exactly what's on the machine, right? You can just run Docker PS or whatever your orchestration method is to see what containers am I running, and that's basically my system. Instead of saying like what packages are installed on this machine and what versions are they and how am I patched for security and everything between all these separate environments, right? It's a little bit more straightforward, and it makes it easier to sort of clone machines without doing some sort of a golden image thing on AWS, for instance. It also isolates processes really well. So if you're looking at sort of a virtual machine, instead of having multiple virtual machines with that same operating system overhead on each one, you now have one machine, many containers, and all those processes are not stomping on each other because they could have separate versions of everything, and it really doesn't matter. They're isolated. So to go over sort of high-level pieces, I would say these are main advantages. It's very lightweight, it's reusable, it's consistent. You get your push and pull mechanism, which is kind of nice. It's kind of familiar to version control. It makes it easy to move containers around, right? And that helps in the context of a pipeline because basically what we're doing is shipping or shepherding code through stages of a pipeline in order to get from development to production, right? So the more portable and the more consistent your code stays between those stages, the higher your level of confidence and the faster you can go and the easier you can automate things. You get versioning, which is great, so you can have people running different versions of containers in different environments. You can work on something that's coming up in one environment and tag it a certain way, and then run latest as your master, or run something called master if you want to tag things and label them that way. And of course, portability I covered. So back to the pipeline. What we want to do in the context of Docker is sort of run unit tests locally, right, against the Docker image. That's going to be running our tests as a method. So what's a common pattern here is you'll have a container that will run an application, but you can also sort of run tests in the same container, right? So you run Docker run, then your container name, and either start or test, right? And depending on where you are in your pipeline, you're going to be running tests and capturing the output, making sure that everything's okay. Or you're starting your container and you're going to run it as sort of a demonized process or a long-running process and keep your application going. So a really common and a pattern that I sort of advise is to build an image that we use to build our app. So you sort of build the scaffolding around the app before you build the container that runs the app. And the reason for that is that the way that Docker does things is it sort of layers all of your changes, which makes it very fast to work with deltas and differences between individual containers. But what you want to do is not have all of that crap in there all the time, because you commonly have things like libraries or packages that you use to compile things or to build certain pieces of your app. And you don't want those sticking around when you're in production because they just make things bigger than they need to be. And they add extra surface area for things like security vulnerabilities. So what we want to do is sort of build a build environment, set that up, to build a cleaner version of our app. Then, so step number 3 would be sort of the compilation step where you're minifying things and you're running, let's say your compilation, if you're building like a Go package, for instance, or you're building your own gem, this is the stage where we sort of build the gem or whatever artifact that we're using inside of our container. If that's a pattern that you've been using outside of Docker, it makes sense to use it inside of Docker until you sort of change the paradigm of your application, right? Then when we build the image that we run and deploy, that is the lightest version of our app. It has the least moving pieces, and it's built on a foundation of those prior to, but without all of the cruft and crap that's involved in them. Because again, we want to minimize the surface area for attacks and make the image as efficient as possible, because you're probably scaling this out. You're probably moving it around a lot. And having your individual pieces sort of segmented out makes it very clear for anyone who's looking at individual containers to see and understand what's going on, right? You want this to be as self-explanatory as possible. And then once we've got sort of our final image, and along the way, I mean, all of these can be pushed to Docker registries, whether it's the Docker Hub or a private registry that you have, or some kind of service like Key.io or something. So there's some pieces that work well as prerequisites, or the sort of foundation behind setting up a proper Docker image and building the environment that we're going to be using. You're going to have some kind of an abstraction commonly between you and Docker, because you're running on a Mac, or you want to isolate Docker from your host machine some way to make it more portable. So this is commonly like a virtual machine. But I'll get into some details about that. So I'm going to start with talking about the outside of our container, like what is going to allow our container to be built and used. And then we'll get into like what happens inside the container in various steps. So the most common pieces here, and I would say the most modern pieces, are something like Docker Toolbox, which has been assembled from different pieces of Docker's open source projects, or I think they might even be private projects. So you can have things like Kitematic, which is kind of like a GUI wrapper for Docker, which will start a virtual machine that will run very much like boot to Docker, if anyone's used boot to Docker before. But that's based on Docker Machine now, which has been created by Docker to sort of give you a VM on your laptop that you can use as a host for your containers. And you can also build your own. So you can run your own VM inside of VMware or VirtualBox that runs CoreOS or any kind of Docker host, so like Ubuntu or whatever it is that you want to run Docker on. And you've also got online hosts. You know, you could do this all inside of an EC2 instance if you wanted to. But it's a little bit more rapid to develop locally. So in terms of container types that we're going to be looking at building, I'm not going to dive too far into this stuff because this is kind of Docker 101 stuff and outside the context of a pipeline, but you kind of have base images, which are the absolute minimum operating system and system packages that you need to sort of kick off this whole process. So you're installing things like Python setup tools, for instance, so that you can compile other packages. Your apt-get update if you're on Ubuntu, so that you get the newest versions of your packages. And this is sort of the base building block. And I advise people to sort of build their own. You can go and look at the community ones. There are verified, secure ones. But it's good to know what exactly is going on inside of your containers. So building your own base image, you're going to have stuff that you add on top. You might have your own custom like apt repositories that you need to add. So that all goes into your base container. Your volume containers are a little bit outside of scope as well, but they're basically your files. So if you want to have a pattern where you're hosting files inside of a separate container that you move through your pipeline in parallel, and then link up to your other container so that you don't have to be embedding files inside of all of these containers, you can use a common volume container. You can have any number of these. And they can each have their own different file systems for different purposes because they all have different pros and cons. Then you have your build containers, which is what I mentioned about like compilation, right? And the run container being the minimum. So inside of a base container, we'll look at this for a little bit. This is basically what I went over, but a key step that I didn't mention is the cleanup. That's important because if everything is based on this base container, you want to make sure that you're going in and cleaning out all of your caches, all of your downloaded packages and stuff, so that that minimal image that you're using for everything, and you probably have 50 copies of, is not like 2 gigs, right? You want it to be as small as possible because it's probably being used all over the place and probably being shipped back and forth all the time. And another key aspect of the base container is it hopefully changes less often than everything else, right? That's another reason to have multiple levels of containers, because you don't really want to be rebuilding everything from scratch all the time. And there's a lot of ways where you can be tweaking things and then have to rebuild your entire container because it didn't recognize that you really didn't change that much. But that's more details about like crafting Docker files that I'm not really going to get into. So the volume container is really just a minimum OS and file structure. You can assemble files in there just like you would a normal file system, and then the actual files themselves. And this can be built based on any kind of trigger, right? You can have your design team just sort of throwing assets up into S3 and trigger a build of a volume container that then makes that accessible to everybody, which I think is a great pattern. So with things like Lambda now on AWS and other kind of triggering mechanisms, moving files around can now build containers and make them accessible to everybody else in your team, which is really great. You can now copy down any number of volume containers, any size. So if you've got a giant site that consists of sort of hero images and then all kinds of other assets and icons, you could have those as separate containers if you wanted to, and have them change independently so that you're not always trying to pull everything at the same time or making everybody download your entire asset library all the time, which is pretty great. And you keep it somewhere centralized so that people can sort of start a new laptop and get everything that they need to run the app or whatever portion of the app that they're running. Again, the build container it's built off of your base. You'll notice that the volume container wasn't built off your base. You don't really need it to be built off your base. It's just holding files. So you can use something like BusyBox or Scratch, which are tiny, tiny, tiny. And all they do is just hold files. But the build container you want to be based on your base container because chances are you're running things like compilations or you're building from source or compiling or minifying stuff. And so you're going to want different tools in there than you had in your base. And you don't want all that stuff sticking around, right? You also want to clean up after yourself. So if you're uglifying things or minifying things, you want to make sure that you sort of get rid of the source files and keep your container size small. And your run container is the built container. That's sort of the build container is building that container. And I don't know how many people are sort of familiar with that concept, but you can have Docker sort of build containers using Docker. It gets way messier than that. But that's sort of a handy pattern because once you get to this stage, you're going to want to be using Docker for everything because you get all those benefits, right? It's very consistent, and you can use it for just running commands. And having all of that context and all of your dependencies in a portable source in a portable binary is really handy. So one thing to consider while you're looking at these multiple containers is that you do have to cascade all of your changes down. So if I change my base, I've actually got to rebuild everything. And you probably want to do that automatically, right? So you want to have that triggered from some kind of a job using continuous integration. And that brings us sort of back into the whole pipeline idea, is that you're likely hitting something like Docker Hub when you do something like this. And Docker Hub will actually allow you to define your dependencies and say that, yeah, this is actually based on my base container. So if I push a change to my base container, please rebuild the following containers. And that's pretty easy to do nowadays. Wasn't a while ago. It might have been a year ago. But nowadays you can sort of have that cascade and have those builds triggered by other actions. And you can do that yourself if you're running Jenkins or if you're running some other CI service. You can have your containers sort of chained together, your jobs chained together, so that when one finishes, the other one sort of starts up as a reaction to that. So one of the most critical pieces of this continuous delivery, continuous deployment pipeline is QA. If we want to automate anything and we really want to turn up the speed, you want to make sure that things are consistent and they're high quality, right? So what does that mean and what does it look like? So this is a little bit beyond the basics of just going through the pipeline. We want to take a minute and look at what goes on at each of these stages and what maturity looks like when you start automating things to ensure that you've got a really high quality and high value change. So at the local level, what happens is you do your unit testing and your mock testing, right? And people are probably fairly familiar with this. This probably happens on your local laptop, in your Docker machine. It can happen outside if there's not a lot of dependencies. But a great thing about running Docker is that you can have all of your tools for running your unit tests and your mocks inside of a container and just mount your source code and run those commands and then get the output and know whether or not you've broken something or there's something like obviously wrong, right? And you want that to happen as soon as possible because you're going to be running that all the time. You probably don't want to be pushing to a CI server to get that done because you want that feedback while you're working, right? To make sure that you're not breaking something and you have to wait 10 minutes to find out whether you've broken something, right? So this likely happens with just mounted code inside of a Docker container rather than packaged code inside of the container. And this reduces waste. I mean, you don't want to sort of start off on the wrong foot. So this is fairly critical. I say I would start with this just because even if you automate everything else, these probably give you a fairly high level of confidence right out the gate. And they're going to help your sort of local development process, which is what you do most of the time, right? You're doing that throughout the day. You might push remotely once a day, but you're going to be in this feedback loop all the time. So once we sort of pass that stage, we look at sort of a centralized environment. We're likely working with something like Jenkins or Circle CI or Travis or one of those that are online, right? They're not local. You can run local CI servers if you want, but kind of the benefit and the focus here is that we're looking at integrating changes with other people at this point. So what does it look like when I take my branch and I compare it to master? I actually test the merged code and find out whether or not I've broken something by the merge itself, or if I've broken something based on someone else's change or a recent change to master. So you want to kind of be merging your code at this stage, and you run your sort of static analysis being, what's the quality of my code from things like cyclomatic complexity, which is a fancy term for meaning like, is it overcomplicated? Did I build things like in a stupid way because I wasn't paying attention or I just like being clever? So integration being that merge step, make sure that there's no merge conflicts. Functional tests, you can hit a couple different things. You could try running the container and hitting an endpoint if you wanted at this point. Regression tests, make sure that nothing that you expect to be working or nothing existing is broken. And cross-device, you can actually be shipping to something like Sauce Labs or any number of services that will allow you to test various devices, right, against this new code. And a lot of people do that if they're in mobile development, right? But you can even do it for responsiveness. There's a lot that you can do here that's not covered, but these are the main pieces that I would say are very important. Testing, this is where we actually look at a deployment, right? So we're probably shipping this to a test environment, some kind of staging environment. And we want to make sure, so the smoke test is basically that nothing is on fire when we ship it, right? Nothing immediately horrible happens. We probably want to run some security testing. We want to make sure that there's no clear vulnerabilities, but you can also do sort of a CVE evaluation against known security issues at this point, because this is where we're sort of gradually hitting longer and more painful tests, but also we want to be increasing our confidence, right? So everything gets a little bit more intense, everything gets a little bit more costly to run and takes longer, but as a result, we're even more confident at this stage. Performance, we can deploy a couple containers. We can be deploying to different hosts and measuring sort of the crosstalk between them. So if we're running tests, we want to make sure that all of our services are communicating and there's not unusual overhead involved in that chattiness, right? If you have a consensus mechanism that you have to run, you want to make sure that that performs as you expect, because if that spikes up, you've clearly got a problem. And you can release it to other developers or QA staff or someone to look at, right, and play around with. And that's when you're going to get exploratory testing, which is kind of a luxury. But this can mean anything where people are just poking it and trying to figure out if it's going to break when they try something, right? An acceptance test being similar to that, just whether or not it does what we expect it to do, right? So you're probably showing that to your product owner or your customers maybe in a sort of demo environment, and making sure that it's what they expect. Because you don't want to do that in production if you can avoid it, right? Save yourself the hassle and the overhead. And finally, we look at another level of smoke testing when we hit production. But what's really interesting here is that we can sort of do A/B testing and gradual rollouts. So things like Facebook does, they'll roll things out to a percentage of their user base. You can do super sophisticated stuff here, right? This is why it's at the end. It's very complicated. It probably takes most of your resources. So you'll see things like Facebook shipped chat. They shipped it like a year before they turned it on, and they just used it internally, right? And it was invisible to users, but it was there in the code base all along. And that sort of dovetails back into the idea of continuous delivery. One of the main principles being that you should ship code even if it's not ready, right? You should ship code merged into your master code, but turned off wherever possible, so that all of your developers have context all the time, and you don't have to be pointing people to different branches and saying, oh yeah, my change is over there. It's a little bit behind master, but take it with a grain of salt or figure it out or whatever. You put everything in master behind switches or feature flags or whatever you want to call them. That way you share context. It's very obvious for people what's going into production, what's half done, what's still to be done. And you don't have to worry about the overhead and waste of managing branches and having to throw them away or keep them, right? So this is very, very important, I think. And I think it's a key piece of continuous delivery. If you really want to run this pipeline efficiently, you don't want to be running this entire thing for 50 branches at a time. If you can keep your branches for less than a week, you're on the right track. And the more easily you can merge to master and put things behind gates, the faster this process is going to run. And the more consistent it's going to be, the less you're going to break it, the less you have to worry about merge conflicts and sharing context with a bunch of developers who are working on different things, right? Everyone is working on the same thing, even if they're on separate areas of the code base. They're seeing everyone else's changes, and chances are they're impacted by other people's changes, right? So You want that to be as transparent as possible and not have to make people hunt for things that are going to screw them over down the road. Another good thing that I should mention. Another key benefit of something like feature flipping or feature toggles is that you can now ship your code and turn it on when your marketing department wants it turned on, which is huge, right? I think that's something that a lot of developers don't consider all the time, but we really are building code for the business and for our customers, and that requires a large degree of coordination outside of just development, right? And that's kind of a big factor in DevOps. It's beyond the two sides that we commonly talk about, but you want to consider the entire process end to end, right? And the value that you're giving to customers. So if you can provide a mechanism where by way of like a Slack command or some kind of chat command for your marketing department to turn on a feature when they've already sent out the email, 2 weeks prior, they've already published a blog post about it, they've already hit social media, and your customers are ready, then you don't have to actually sync everything up so that it all happens at the perfect time, right? You can sort of offload it and move on to the next thing and say that, just turn it on when you want. It's going to work, but it's up to you. And I'm going to move on to the next thing, and I'm going to build the next thing that I have to build. And that way, you're not stuck waiting for a deployment process to finish. It just sort of runs continuously, right? So here it is, basically all on one slide, but keep in mind, you don't have to do all this all at once. Pick out what's highest value to you, and I would recommend sort of starting from the upstream and going to the downstream, because you sort of order things by complexity that way. And here's what it sort of looks like in a common system. This is CloudBees, which is Jenkins, but you'll see that there's sort of sequential progression through several builds. It's kind of a simple representation, but I wanted to provide something to put it in visual context for people. That this is commonly what it looks like, but there's all kinds of different systems. So what you do to sort of implement this on a local scale, if you're going to do this in-house, if you're going to do this on your local laptop, you're probably using something like Jenkins or GitLab. Go is another one from ThoughtWorks that's continuous delivery focused and very pipeline focused. Jenkins is not pipeline focused, but you can install plugins that will make it a little bit easier to deal with. Strider is one that I learned about probably in this room last year, which is really awesome. It's just a node package, I believe, and it runs a CI server that you can run locally. It's very lightweight, very easy to use. And if you're in the Windows world, you can run Team Foundation Server or something similar. And in the online world, you have options like Shippable, which is a great Docker-focused CI service. CodeShip is another one that's recently adopted Docker as sort of a moving piece. Circle's been Docker, I think, for a while. Travis is also Docker-focused. A lot of these were using Docker before they sort of accepted Docker as a customer tool. They were using it behind the scenes because Docker is great for CI. You can just build things and tear them down, and it's very efficient, right? And AppVeyor, I think, it's in the Windows world. Luckily, outside my scope. And then in the build world, you've got Docker, where you can build containers. You can use Packer to build containers as well. Docker Hub will build them automatically based on Git triggers or any kind of manual intervention that you want. So that when you push to GitHub, for instance, and you've got that integration, it will build. And as I said, it would build your dependencies based on whether or not your base container changed. It will cascade down and rebuild. Key.io is another common build. I think they do hosting as well. And any CI tool can build Docker containers as long as it can run Docker, right? So common deployment pattern. You pull from the hub, right? Or you use configuration management to pull from the hub. But you can pull directly, right? So what you're doing is you're sort of pulling your container from the registry that you've published to. And then you want to swap it in and make it live somehow. You commonly do that by like a DNS change or some kind of orchestration service, right? You can use service discovery techniques. But if you look at the whole shebang, all the way through, you'll see that your build is triggered by a code push, which probably goes to something like GitHub. Then you've got shippable, which accepts that trigger and starts your CI process. Then you're publishing that successful build to a registry, whether it's Docker Hub or something else, and then to your host. So this is an Elastic container service. It could be Kubernetes. It could be any kind of Docker host that you're running on. And commonly what happens is that it doesn't actually go live until you trigger it some way, right? So you trigger the build automatically, but you don't trigger the deployment unless you want to automate that step. And you'll trigger it from something like Slack. That's the hashtag. And you can set up things like Zookeeper, which is behind Helios, which is a Spotify thing, to automatically trigger things like cycling in new containers and pulling out old containers. But there's a lot of orchestration options there. And I'll provide some resources afterwards that will go through it. You can trigger with Ansible or some kind of other configuration management service, right? So if you wanted to run a command on your local laptop and that starts to deploy, that's also an option. You could have Slack trigger Ansible if you wanted. Or you could trigger it with CI as well, right? You can use Jenkins to start a job that deploys your code. So where do we go from this point, right, where we sort of understand how to build a pipeline and what's involved? Really, it's just increasing your automation, right? And we're sort of in this golden age where we can automate all kinds of things, and they're very possible, but they're not often easy. So I would say go with caution, and try and sort of tackle the smallest thing that you possibly can. Or else I like to say that bad automation is basically like errors as a service. So be careful as you go. And there will be a lot of automation coming with Docker. It's inevitably going to happen that everything is going to be automated. It's just a matter of time. So you'll see a lot of things coming up, but there's no sort of clear silver bullets or patterns yet in the world of automation in Docker. I want to talk a little bit about bots because I think bots are the nice glue that happens around something like a deployment pipeline, and more specifically around chat ops. So I actually searched for this word collab automation, and Google thought I meant collab tomato, which is pretty awesome, which I wasn't aware was a word. So you can host any of these sort of bots to run all of your jobs and abstract them away from people having to run commands off on a server that's not visible to people. And you can use sort of Slack and FlowDoc or HipChat or whatever it is to run these bots. Pretty much everything will run them now. Even Skype runs bots. And they're fairly simple to spin up because they're all open source for the most part and pretty easily extendable. And the benefit being, like, when everything happens inside of your chat, everybody sees it. Everybody understands, context and shares the interactions, right? So they understand, like, how the job gets kicked off, or when the build is ready, when we have a new version of the software. It's all in front of everybody, which helps with context sharing and onboarding people and helping everybody stay on the same page. So I'm kind of running out of time. I think I have enough to cover this. So I want to sort of provide a little bit of advice. First, again, Docker is changing quite a bit. There's a lot of moving pieces to consider. And think about the fact that it is changing a lot. And if you are not at a high level of maturity, you're probably going to be trailing behind it, trying to catch up with all of these changes, unless you've got all your ducks in a row and you can sort of change individual pieces as they become relevant to you, right? So make sure that you cover the foundations first, because there's a lot going on here, and it helps to be it helps to be aware of it. So you have things like scheduling that you have to consider. Scheduling is basically the practice of putting a specific container in a specific place at a specific time, and that happens when you scale up and you have multiple hosts hosting your containers, right? That's something you'll run into almost right away. You have storage. How do you move files around? Do you move them around? Do you put them in containers? Do you not? You have options there, right? There's a lot going on. Service discovery is a magical thing, but often very complicated and relies on pretty sophisticated systems. You have to consider things like consensus mechanisms and large-scale redundant distributed systems. So you're probably using something like Zookeeper there, which if you've never used before, probably try and use it outside of Docker before you use it inside of Docker. Become familiar with it before you just spin up a bunch of containers, because it comes with costs. If you run a large-scale distributed service discovery system across access or availability zones in AWS, for instance, you'll run up thousands of dollars in crosstalk fees, because every change you make has to be propagated all over the place, right? And I see that all the time. Everyone talks about, yeah, we implemented service discovery, and then all of a sudden, our AWS fees went crazy. Logging and monitoring, that's not trivial either. Good patterns there are sort of logging and monitoring from outside the container by hooking into Docker rather than adding something inside your container that's publishing out, because Docker will just basically pipe all of your logs through its own system, and sort of hooking into that is a lot easier than trying to put something inside your container. That's kind of like an old pattern that's now been refined a little bit. Networking is a mess right now, frankly. There's all kinds of options. There's Flannel, Weave, Calico, and these are all very rapidly changing options. Docker just bought a networking company a little while ago, but they haven't fully integrated it yet, so that's going to be changing quite a bit. And other things to think about, like how do you decide whether or not your containers are healthy, because that will dictate whether or not you want to make a container active, right? So the sort of final smoke testing piece, there's a lot of options there for validating whether or not a container is ready to go. And how do you roll back? So once you deploy something and you decide you don't like it, or your marketing department wasn't ready and they accidentally turned something on, how do you go and undo your changes, right? Because we can ship things through production. You should probably spend a little bit of time thinking about how to undo things that we ship to production. And failing gracefully, so if you suddenly have a bunch of services that are coordinating with each other, what happens when one of them dies? Does everything die? How do you find out when something dies and what the reaction is? Secrets are a wonderful problem to deal with. There's a lot of patterns there, but how do you deal with things like your AWS keys or your private keys or SSL keys and stuff like that? Scaling, again, there's a lot of auto scaling that's possible with systems like Docker, but you want to be aware of what the patterns are and how it works. And then cron is just basically scheduling operations, because that doesn't go away. You still have to run things on a regular basis, depending on your use cases. So I would say change as little as possible while you're starting out. Start really small, iterate on your progress, and just basically aim for isolating variables, so that when you change something, you know exactly when something broke, that it was probably that thing that you changed, rather than it could be anything, because we changed a bunch of stuff. Great things here are sort of like using volume containers to make backups. That's a pattern that I didn't talk about a lot, but is certainly helpful. And I would say, like, while you're starting out, like, aim for very specific things, right? Don't say that we're going to deploy automatically as a starting point, right? Like, ramp up to that. Start easy. Start by just running tests on another system that's not your own system. and go from there. And security, I think, is something that doesn't get enough attention at all, especially nowadays that you can sort of automate at a large scale and roll out change all across your system and probably automate your production deployments. Think about things like how you manage keys, how you manage like permission to the system, who can actually run jobs and stuff. And plan your access. Do things like game days, like actually test whether or not people can hack the system, or what happens when you lose an employee, right? If you had someone like walk out of your office and never come back, how do you rotate all your keys before they get to another computer, right? Or potentially before it causes a problem. And I would say start preparing your apps for Docker wherever possible. You can look at a greenfield project. Try with something that is totally Docker oriented. Start with a Hello World example. Get used to the patterns of pushing and pulling and building and running. And then look at what it would take to sort of retrofit your existing applications in Docker. And it probably involves splitting them out quite a bit, rethinking how you do things, because the patterns are very different from your typical sort of monolithic application. There's nothing that stops you from running a monolithic application in Docker, but you'll probably have a bad time because you'll be constantly rebuilding everything all the time, and it's going to be massive and messy. And you're not sort of removing your variables. You're just moving your existing mess into a level of abstraction away from having it be straightforward. And I think that's it. That's it for me. I might be out of time. Yeah.